put all of our perfect squares up on top. Where else can you find your perfect squares? That's right, on your flowchart, on the yellow sheet. Okay, we got our perfect squares there. All right, everybody know how we get perfect squares, right? 1 squared, 2 squared, 3 squared, 4 squared, dot, dot, dot. This is 20 squared. Okay, so if you want to put those in there, by all means, go ahead. Ladies, quiet. Have fun. The number R is the square root of the number. And R squared equals S. A positive square root S has 2 square roots denoted by the square root of S and the opposite of the square root of S. In other words, if I have the square root of 4, it's going to be plus or minus 2. Okay? Yeah, what you do here is you find when you simplify in radicals, you can't put them in a calculator and get a decimal because that is an approximation. And we need the real values. Okay, so how you do this is, for those of you who did not do this in Algebra 1, you take the factors of 24, pardon me. Here, write yourself a pass. You can write yourself off. It's a joke. Get it? So, write down the factors of 24. I have 1 times 24, 2 times 12, 3 times 8, 4 times 6. Did I miss any? Well, you should be able to do this in your head, right? Times tables. Please have my students remember times tables, please. Okay, then you look at this and you look at these factors and think about the highest. Well, first of all, what are the perfect squares of these factors? 4. 4 is one of them because it's up here. 4. Any others? No. So I'm going to split this square root of 24 up into square root. I'm going to put my perfect square first. 4 times the square root of 6. And then I can actually take the square root of 4. What is it? Yep. Don't forget the plus or minus. 2 square root of 6. Nope. The only easier way to do that is just have your brain do it for you. Bless you, my son. Yeah, you guys should have spent a whole unit on this in Algebra 1. Okay, square root of 12. Like, I know what the answer is because I just did it in my head. 2 square root of 3. It's not superior. It's just knowing what your times tables are. No, I'm not superior. 1 times 12. 2 times 6. 3 times 4. What's my largest perfect square? 4. Right. So I like to put the perfect square first. Square root of 4 times the square root of 3. Square root of 4 is, yep, 2 square root of 3. No, unfortunately. How about the square root of 48? Oh my God, here we go. 6 and 8, 12 and 4, 1 and 48, 2 and 24. 3, oh, 3 goes in there, doesn't it? 3 goes into 4 once. So I have 18 left, so 16, right? I got 6 and 8.
Okay, so
Any others? 16 is your largest perfect square. Okay. Square root of 16 times the square root of 3. What is the square root of 16? Pardon me? No, because I've already taken the square root. How about the square root of 52? 1 times 52, 2 times 26. 3 go in there? Nope. How about 4? 4 and 13. That's probably going to work. 4 and 13. The what? I don't remember. You're not going to have this test until after Thanksgiving. Well, we're going to have a quiz. I don't care. You guys take it within the next 3 days. You can take it any day. It'll be ready tomorrow. I'm just going to have like 6 factoring problems. If you want to take it tomorrow, take it tomorrow. If you want to take it Monday, take it Monday. If you want to take it Tuesday, take it Tuesday. What? A what? I could if you want. Because you've had quite a few factoring problems already. All right. So I'm going to write square root of 4 times the square root of 13. Square root of 4 is plus or minus 2, square root of 13. What about fractions? Yes, skip them. There's a property that says I can split these up, right? Do you remember? Square root of 4 over the square root of 9. This one's easy because they're both perfect squares, right? It's going to be plus or minus 2/3. Now, the other one. This is where a student starts skipping it. Because when you split this up, here we go. I cannot leave a radical in the denominator, correct? So how do I get rid of a radical in the denominator? Multiply it by itself. So I'm going to multiply this fraction, and it's got to be 1, right? I can't really multiply it by anything other than 1, because I would change the value of it. So I'm going to multiply it by radical 3 over radical 3. Because radical 3 times radical 3 is what? Well, radical 9, which is 3. I get what's inside the radical sign. Okay. Now, radical 2 times radical 3 is radical 6. You're multiplying. Okay, this is plus or minus. When you multiply a radical, it can't have a radical, it can't have a square root or any kind of radical sign. When you're multiplying radical 3 times radical 3, the theory behind this is really, remember when we changed the exponents? It's 3 to the 1/2 times 3 to the 1/2. And when you add the exponents, you get 3 to the 1. That's why you get 3. Okay? That's the concept behind it. Now, some of these don't work out so nice. Radical 6 radical 6 divided by radical 11. So what am I going to multiply this by? Yep, radical 11 over radical 11. And I get radical 66 over 11. That's plus or minus. Now, here's what's really sucky. It could even be extended more. We can't simplify radical 66, but sometimes you get something where you have to simplify farther numerator. That's why a lot of times students get to this point and skip it. Okay, you're asking me, well, what has this got to do with solving quadratic equations, right? Well, the next section, part 2, solve each equation. Yes, Chad. I'm not, it worked for number 7. 2 times 3. What do you get the 2 and the 3? I don't have a 6 over 3. I have a square root of 66 over 11. All right, let's solve some quadratic equations by taking the square root. Number 9, this one's easy. How do I get rid of the power 2? Take the square root of both sides. Cancels out the power 2. I get x equals, what's the square root of 16?
4.
Correct, plus or minus 4. Those are my x-intercepts. Okay, here comes the fun stuff. Coming down the pipeline. I have to get x squared by itself, so I'm going to divide both sides by 2 first. Right. Thank you. Not just 5, but plus or minus 5. How about number 11? This is where the stuff starts getting funner. Yep, going to subtract 1. Going to start there. So I get 2x squared equals 7. Then I have to divide by 2. Oh, look at this. We get fractions on top of it. This is so much fun. Funner. Equals 7 halves. Now what? Square root both sides. Oh, isn't this fun? Okay, so I get x equals plus or minus the square root. I'm going to split that up, okay? Square root of 7 over square root of 2. Sorry. I'm so sorry. I'm having so much fun. It's hard for me to slow down. Well, let me ask you, is that the answer? You guessed that? You guessed right. What? Huh? All right, why am I not done? Because I have a radical in the denominator. I have to get rid of the radical in the denominator by multiplying it by radical 2 over radical 2. So my answer is plus or minus radical 7 times radical 2 is radical 14. And I get what's inside, which is 2. And no, they are unlike terms. I cannot divide them. Are we done now? I don't know. I don't think so. Okay, that is, I'm done. All right, let's go on to part 3. Want to do 12? I don't care. All right, add 5. Add 5. I get x squared divided by 3 equals 12. Let's see, multiply by 3. Oh, this one's actually kind of easy. So I get x squared equals 36. What does x equal? Yeah, plus or minus 6. You must have Mrs. Adams for a teacher. Who? You? I know she does radicals. All right, can we go on? Number 13. Number 3. They're giving us a hint. Radical goes in the back of the answer. Okay, well, whatever that means. All right, so I'm solving for x. I don't like fractions. I don't even like dealing with fractions. How do I get rid of fractions? Multiply both sides by the reciprocal. In this case, it's just 3. Cancels out. I get x plus 5 squared equals 21. With me? Are you with me, kids? Well, it's 3 over 1. Yeah, they cancel out. They reduce to 1. Okay, we ready? How do I get rid of the power 2? Square root both sides. So I get x plus 5 equals plus or minus the square root of 21. Can I simplify that? It's not a matter of desiring. I desire simplifying everything. Okay. No, we cannot simplify the square root 21. No, it's still got to get x by itself, right? Minus 5. Minus 5. Okay, so what does x equal? Negative 5. Very, very good. Because it says radical goes in the back of the answer. Number 14 is really not that much fun. 15 is going to be funner. Let's do 15. It's funner. Sure. Okay, 15. I need to multiply both sides by what? 2. Okay, so I get x plus 8 squared equals 2 times 14, 28. What? Thank you. Wow, that worked. That never works. That never works. Worked that time. Okay, now what? Square root both sides.
You know what to tell, Mr.
Okay, so I get x plus 8 equals plus or minus square root of 28. Can I simplify to square root of 28? Yes, no? Because I know my times tables very well. Well, I know my times tables. I mean, I'm a math teacher, so it's like, it's embedded in my brain. And I know the perfect squares. So it just naturally comes, huh? So, since what? Yeah, I'm gonna have to calculate. And at the same, yes, sir. I have to get x by itself. Well, I'm gonna do two steps at once. Yeah, moving the 8 over. So x equals -8 plus or minus, and at the same time, I'm going to simplify the square root of 28. See, I'm going to have 1 times 28, 2 times 14, 3, 4 times 7, and that's it, right? And if I check my chart, 4 is a perfect square. So I'm going to make this square root of 4 times the square root of 7. The square root of 4 is 2 square root of 7. How about that? That nifty or what? You don't? Are you really? You don't understand it? Well, let's go back and do 14. Okay. I'll just keep doing them until you guys get the hang of this. Let's do 14. Okay. My ultimate goal is to get x on one side, right? So I'm going to get rid of the 5. I'm going to divide both sides by 5.
Why can't I divide both sides?
Shut up. I have x minus 1 squared, 50 divided by 5, 10. Are you good? Are you good? Okay. Now I'm going to get rid of the power 2 because that's next in line to get rid of. So I'm going to square root both sides to get rid of the power 2. Right. Now that my x minus 1 is all by itself, I can drop the parentheses. Okay? So I get x minus 1. Whenever I take the square root of a number when I'm solving an equation, I have to use the plus or minus. Doesn't matter. Square root of 10. Now the only way I can get x by itself is plus 1. So I'm going to add 1 to this side. These cancel out to 0. I get x equals the whole number comes first, positive 1. Yeah, you cannot simplify the square root of 10, so just leave it. But there was a factor of a perfect square in 28. Factor means it's one of those numbers being multiplied by another number to get a product. Hey, should we do a word problem?
No.
Let's do this example 4 thing. Okay, How you doing, Beth? Example 4. When an object is dropped, its speed continuously increases, and therefore its height above the ground decreases at a faster rate and faster rate until it hits what? Terminal velocity, right? The height in feet of the object each second after it drops can be modeled by the function capital H equals negative 16 t squared plus h of 0 or h naught or h0. This is our initial height, where h of 0 is the object's height. Huh? I just have videos on it. I haven't made an actual channel yet. I have a YouTube site. Just put in my name, go to YouTube, or you can go to Google Classroom. They're all attached to the lectures. Yeah, you can subscribe to my YouTube. All right, so this model assumes that the force of air resistance on the object is negligible, which is probably false. This model works only on Earth because of the negative 16 feet per second, right? This is gravity. A stuntman working on the set of a movie is to fall out a window 100 feet above the ground, probably because he jouled a THC or something. Okay, for the stuntman's safety, and an air cushion 26 feet wide by 30 feet long by 9 feet high is positioned on the ground below the window. Okay, I'm thoroughly confused. Okay, so let's try to draw a picture about this. I attach videos to every lecture. I attach videos to every lecture. Yeah. Okay, what? Well, I don't know. So let's draw a picture of this. Here's my height. Here's my time. So let's see. I don't care how big this air cushion is. I care about how high it is. So my ground now is at 9 feet. Yes. Lithuanian, yes. All right, so for how many seconds will the stuntman fall until hitting the cushion? So he starts at an initial height of 100, right? It's my h of 0. So we need to fall. This guy's going to fall, because he ate some THC. And we need to find this point. Okay, so we're supposed to use, let's see, my height equals negative 16 t squared plus my initial height is 100. And we need a height of 9 feet, right? It's not 0. So I'm going to replace this with 9. But when I go to solve this, I need a 0 on one side, so I'm going to subtract 9 for both sides. Now I get my 0. Equals negative 16 t squared plus 91. Now I'm going to shove that in my calculator. Thank you, ma'am. Yes. Well, good for him. Okay, negative 16x squared plus 91. I'm going to graph that sucker, and I'm looking for the x-intercept. I think I can do this without messing with my window. Okay, second trace, I need the 0. My cursor's at x equals 0. I need it close to x equals 2, so I'm going to keep going to 2. 2, 2, 2, 2. Oh, there it is. So I hit enter for my left bound, enter for my right bound, guess, and it's going to take 2.38 seconds. I put in my y equals negative 16x squared plus 91. Huh? What? Well, I'm assuming that this is a review. Do you want me to use perfect square? I'll still get 2.38. All right, let's do it on perfect squares. Okay, so I have 9 equals negative 16t squared plus 100. So I'm going to subtract 100 from both sides. So I get negative 91 equals negative 16t squared. Then I'm going to divide both sides by negative 16, negative 16. So I get t squared is going to equal negative 91 divided by negative 16. Negative 91 divided by negative 16. I get 5.6875. Now, normally, I would use a fraction, but since this is a real-life problem, I can use decimals. And I should use decimals. Okay, how do I get rid of the power 2? That's right, take the square root of both sides. So t is going to equal plus or minus 5. I'm going to take the square root of 5.6875, and I get, guess what I get? 2.38. Now, do I care about the negative 2.38 seconds? No, unless you're Sheldon Cooper, you cannot go back in time. Personally, I wouldn't do this any other way but putting it into my calculator. Hey, your practice work. Your practice work start here where it says more practice. So, have fun with your homework tonight. All the problems we didn't do. You guys have books? Ooh, you do have bookwork too. So do one or the other.
One or the other. Gotcha. I didn't. I got you. I'll just. Well. All. Points. Mostly because.
Tom Cruise dropped